Okay, so I'm back, and this unit on corrosion is going to actually be pretty short. So I know you're feeling relieved about that. Corrosion. We're going to talk about specifically about corrosion of iron, although a lot of this can be applied to things to other metals like aluminum. Aluminum corrodes as well, but it is different. It is not so dramatic because when aluminum oxidizes, it forms a protective coating on top of the magnesium. I'm sorry, on top of the aluminum, which keeps it from further corrosion. So it doesn't. Whereas with iron, it will continue to corrode until it eats right through to the other side of the metal, which is really detrimental. So in order to get a handle on this, we're going to use this diagram here. And so what this is iron. So this is iron here, elemental iron, and this is water. And one of the things that is normally not quite apparent from the outset is that this is exposed to the air. So this is the oxygen out here, and there is an actual concentration gradient where toward the outside this is oxygen rich, and as you go inward, the oxygen content drops. And so in here, this is oxygen poor. I'm just grabbing something here. So what happens, this oxygen rich part, this is really the cathodic area. So this is the cathode. So this is where reduction is going to take place, and the reduction is going to be of the oxygen. So if we have oxygen oxygen will dissolve in water. So we have dissolved oxygen, and what's going to happen is that it will be reduced in time. But let's complete the idea down here. This here is the anode part of things, and this is where and this is oxygen poor. Okay, and so this is where the oxidation is going to take place, and this is where the reduction is going to take place. So what happens is that at the anode, the reduction of iron follows this. Goes to Fe2 plus the 2 electrons. Okay? And so these electrons, I'm going to do it in, I wish I had another, I'll do it in red. These 2 electrons will travel through the water and will reduce the water to 2 oxide atoms. Okay. Now, what happens here is that the overall reaction that causes the rust is actually not formed right away. There's an intermediate. It goes like this. The iron 2+ from here plus water okay plus I need another color. I'm going to do this one. Plus these oxides. Will produce the intermediate, which is FeOH2. Okay, so, and that's what you'll see, do this in orange. That's what you see forming on the surface. And I haven't done it in the middle, but if you can imagine this, there's a little shaded thing here. And this one you can see a little bit better here. So this forms on the surface, and this in turn will undergo a second reaction, and this will produce Fe2O3. So this is iron 3 oxide, and that is what we know as rust. Okay, so this is, so corrosion, rusting is actually a redox reaction. It's a very slow one, but it is set up through the oxidation of iron and the reduction of oxygen that was in the air. So that's why we end up with an iron oxide down here. Okay. Now, one of the things that is really interesting is that if you use like pure water in this system, the oxidation reaction is actually slower than if you added a little bit of salt into the water. So we're talking about what's the difference between a say an aquatic environment like a lake or a river as opposed to the ocean, the marine environment. Well, you probably have heard in the past that ships, seagoing ships, are constantly in a state of being repainted. And the reason why the ocean-going ones are is because the salt is present. Well, if you have salt in here, you have ions in here, this makes it easier for electrons to flow through. Okay, so that's why marine environments are more dangerous. So I'm just going to make a little note to that on top. Marine oxidation is much more rapid. Because electrons flow more readily. In an ionic solution than in pure water. Okay, so that's how that occurs. Now, there are some ways that we use to battle corrosion, and that's actually kind of like over on the next page on this one here. As I said, painting, I've heard the anecdote that by the time the paint crew finishes painting its way around the hull of a ship, it's time to start again. So there's a constant recoating of the ship hull. Now, the paint that they use it has often got a metal in it, like it's a lead-based paint, or it has zinc in it or something to help supply electrons to the iron. So that's so constant painting just to as a form of separating the iron from the atmospheric oxygen is one strategy. The other strategy is to galvanize. Galvanization just means a coating with zinc. Now, what zinc does is zinc will oxidize to Zn+2 and give up its 2 electrons. So what the 2 electrons that it gives up, this will be, if you have rust available, or if it's oxidizing, these will add to here to try to keep it in. Okay, okay, I got to pause here. I will be right back. Sorry about that. My wife is on her way to work, so I had to give her goodbye hug and kiss and send her on her way. So you can see what's happening is that the iron is taking electrons from the galvanization with zinc and using them to keep the iron in its elemental form, and that is in a way the same thing as what's happening in this what we call cathodic protection. I don't know if you've ever noticed this. If your family has an outboard motor, if you examine it on the outside, somewhere on it, there should be a little block of metal. Okay, and often this is magnesium or zinc. That what happens is that this will break down in time in the same way as this does. For magnesium will break down, oxidize to produce electrons, and these electrons will go out into the motor and supply it on an ongoing basis with electrons. And it's these electrons that do the same thing. They try to keep the iron in its reduced state. Okay? Now there's that way, but this only works well for small motors and such. If you're talking about a larger ship like this, then you got a problem. If I was to attach a magnesium block on this hull, it would only radiate to a certain distance, so only a small part would receive adequate protection. So what they do is they just supply. You have a low level electrical current always going to the ship's hull, and that is enough to keep it from, or at least to help prevent the corrosion over time. Okay, so I think that's it. That's it for this this unit, and yeah, hope you learned something out of that. I think there's actually some videos online that if you wanted to look at cathodic or cathodic protection, that they would walk through this with you. If you have any questions, of course, you can give me a shout through Zoom, or you can text me or whatever. Anyway, we'll see you next day. Next day we are going to look at electrolysis, and then we'll look at electroplating. And then once we do that, believe it or not, I'm pretty sure that the course is done. That's the last few topics. Anyway, signing off now. Bless you. Bye now.